We said that in this chapter we are going to cover some data structures. What are they? Actually, the most popular ones. Beside the fundamentals, we have the stacks, queues, DAX, lists, and we will also cover how we are implementing this type of data structures by using the main data structure of Python, which is list, as you know, since all of you have finished Python tutorials, you already know what a list is in Python environment. And then while going through these data structures, we will discussing some problems, we will cover some examples and see the advantage of these special data structures. And he said that there are mostly linear data structures, except the tree data structure. It's not a linear data structure, but the other ones we just talked about are all examples of linear data structures. They sometimes have an ordered fashion or unordered fashion, it doesn't matter, but you can easily add or remove items from the top, from the bottom, or from the front, from the back. It's up to your, let's say, terms you are using while writing or explaining your algorithm. You can even sometimes add new items into the intermediate positions or remove some intermediate items. And these are possible if you can write some proper operations on your data structures. They have always two ends. We sometimes use left, right, sometimes front, rear, sometimes top and bottom to refer to the ends of these data structures. And we said that the first one is stacks. And stacks are kind of an ordered collection of items. And the thing is that we are adding these items always to the top. So the first item you put into the stack will always remain at the base of the stack. So that's an important thing. You should be aware of it, since it will be quite difficult for you to reach to this base item. And then you continue adding items. But once you want to remove an let's say item from your stack, then you will simply pop it and the topmost item will be removed. So if you want to remove, let's say you have 3 items in your stack and want to remove the base item, then you should perform 3 pop operations so that the base item will easily be removed. So we can say that it's the last in, first out type of data structure. The item you put first will easily be taken out first. Last in, first out. There's another expression actually stating the same thing. Newer items will always be near the top, but the older ones will be close to the base. So we have some examples in our daily life: stacks of books, notebooks, stacks of trays in a cafeteria, or web surfing. When you continue clicking and want to go back, you will always reach to the last website actually you visited, not the first website you visited. And we can also use the stacks simply to reverse the order of items. If you look at the simple, let's say, arrangement, in the first, while you are actually putting these items into the stack, this is the order. 4 is the first and 8.4 is the last item. But once you remove the items from the stack, then 8.4 will be the first item, but 4 will be the fourth item in your new, let's say, output list. So we can say that the stacks can easily be used to reverse order of items in any kind of list. While implementing such a stack data structure in a programming language, you should at least have these operations. The first operation is simple. You simply create a stack data structure by using the fundamental data structure of your programming language. And then another operation is pushing an item into the stack. Since we are constructing a stack data structure to store items. So how we do that? We simply use the push operation. We put items into that stack with that specific operation. And then we need a pop operation. Is for removing the topmost item. And as you see in the stack, we cannot actually remove an intermediate element, intermediate item. It's not possible. And then peek is very simple. Peek gives you the topmost item. It doesn't remove anything. It just actually stays, you returns to the topmost item, whether it's a number, text, string, it will give that value. Then the last two are not that complicated. IsEmpty is, as the name implies, once you run it, it will tell you whether the stack is empty or not. If it's empty, it will give a true value. If it's false, if it's actually not empty, if there are no items in the stack, then you will get a false result with this operation. And obviously the size operation will give you the length of your data structure, how many items you have in your stack. And if you remember, we did actually go through this example. Here we start with an actually, we are assuming that S is already created. So at some point above, we use this operation, stack operation, which means that S is equal to stack. And we created such a stack data structure S. At the first step, actually, we are checking whether this one is empty. And it's obvious that since we just created it, it should be an empty stack. And as you see, the operation returns the true value. And then we continue adding some items. We are pushing forward, pushing dog. So we will have two items. And since dog string is the last item in the stack, once you run the peek operation, it will return you the topmost item, which is this string. And then we add another item, true, check the size of it, obviously it's 3. And then now we run the first function, the first operation once again, and check whether it's an empty stack right now. And obviously it's not empty since we have 3 items, so this will return a false value. We get another item, then pop the topmost item. This was the topmost item, so the result will be 8.4. And as you see, the number of items is decreased since we have used the operation pop. Another pop operation, true is removed, and it is a returned value. And we have 2 items left. Once you check the size, this will return you the size of the list. So you have a question, is list a stack in Python? No, not really. It has similarities, but not complete. Now we will see the relations, how we can actually use the list data structure of Python to construct stack data structures. This is a stack class, as you see. Once you run it, once you create an object with this class, and that means you now have a stack data structure. So once you create it, this is actually creating an empty list, as you see. So I can say that this is the first operation, stack. So now let's look at the second operation. Since if you are going to construct a stack data structure, then you should at least have these operations. Now the first one is okay. Let's have a look at the second one, whether we have push item or not. If there is no such an operation, you should have it. Yes, this is the push operation, or in Python, push definition. So it takes an input, as this is the input, an item, and then what it performs is that it uses the operation of list. It appends this item to the end of the list. So this is very similar to the list data structure without noting the actually specific position of the item. Once you use an append operation, Python will obviously add this item to the end of the list. So we can say that this simple function, the simple append function, is the same as the push operation here. Now this is done, and let's have a look at pop operation. So in the pop operation, we need to remove the topmost item. That's, as you see, it's again much simpler. We have a similar operation in Python list. Even the names are the same. So once you write items.pop, it will remove the topmost item. So we can say that push and pop operations are exactly the same with the stack data structure. Let's have a look at the peak operation, the topmost item. It will not remove anything, but will just give you the topmost item. This is here, so it's a bit different. So we don't have an exact peak operation in the Python list, but we can easily construct it by using such a thing. What we do, we first find the length of the stack, and then try to actually give the topmost item. So why we do that? Yes, seeing that we have a list and it has 3 items. This is the 0th item, first and the 2nd item, right? So if you run the length of this list, it will give us a value of 3, right? 3 minus 1 will give us this position. So once you actually call the 2nd item in this list, it will give us the topmost or the uppermost, let's say, item value in our stack data structure. So it will be the peak data structure, the peak operation of our stack data structure. Now we are done with peak. So let's have a look at isEmpty and the size functions. They're not that complicated. We have the isEmpty here. So we check whether this created list is equal to the empty list. If it's an empty list, then it will directly output a true value. But if it has some other items inside, then it will give you a false value. Now let's have a look at the last one, which is very straightforward. We have a similar function in the list data structure of Python. So if you simply run the length operation for that list data structure, we can simply get the size of the stack. So any questions, guys, here? So there's a question, can we say self items minus 1 as well? What do you mean by that? I think, are you referring to this part? So you can pick the value by using such an operation from the list data structure. Any other questions, guys? You can unmute yourself anytime. It's no problem. While I'm talking, you can simply unmute and directly ask your question. Okay, so we're going to use actually these stack data structures. First of all, this is actually kind of a balanced parentheses expression. As you see, there are many parentheses, but they are all balanced. And you can check whether the given expression has a balanced parentheses or not. So what do? You may have a stack data structure. While you are scanning this expression from left to right, you can put these left parentheses into the stack. And then once you come up this point, let's say, once you see a right parenthesis, then you should remove one item. You should pop an item from the stack operation, stack data structure. Let me draw a kind of a stack here for, I think, yes, in maximum we will have, I think, 4 items. So this is the larger one, and it's smaller one. While I'm scanning this expression, while going from left to right, when I see a left parentheses, I put it into the stack. Okay. This is what I'm doing right now. So this is actually the fourth item, the fourth parentheses, left parentheses, okay? Now when I come to here, I see that there's a right parenthesis, so what I do, I simply pop this item. So this is popped, and then I come to that right parentheses, and again, I pop one item here. When I come here, this is a left parenthesis, so I need to add one more item into my stack. So this is actually the one I just put. And then when I see the right parentheses, I will pop this one, and I have two more right parentheses, and I can simply pop these two, and then at the end I will have an empty stack. So if you conclude that at the end of this scanning operation you have an empty stack, then that means this expression has balanced parentheses. Okay, you can also do the same thing with different parentheses, no problem. Just the important thing is that you check whether it's a left parentheses or a right one. In question about this scanning operation, since you're going to use actually such an operation in your first mini project. And then we have another example actually. This is converting decimal numbers to binary numbers. So how we are going to use actually a stack data structure to convert and let's say decimal number to a binary number. Any idea, guys? If you have gone through the lecture notes in advance, you should know how we are going to do. Do you remember from your, let's say, high school years or maybe some other courses, how you do this conversion? What do you do? We simply divide the decimal numbers by 2 for many times. So what is that? 116, 232. We will have just 1 here. And then as you see now, I will continue dividing the result by 2. Again, I will divide it. I will have 0. I will have 1. I will have again 0. And then 1. I'm about to finish. Right? Is it okay, right? Okay, so what we do after you have done with this division, set of divisions, then you can simply write this binary form of the decimal number by using such an traversal. So I will use first 1, 1, 1, 1, 0, 1, 0, 0, 1. So it's exactly the thing actually written here. So in binary form, this 233 is represented as 111011001. So this is how we do the conversion manually. And where can we use, while if we are going to implement this actually kind of conversion by using, let's say, Python programming language, and we want to use a stack data structure, how we can do that? Any comment, guys? Any answers? Where we can use the stack data structure? So it says that once we do the divisions, we may add the remainder into the stack. So this is the remainder. Let me have a kind of a stack here then. Besides that, we will put first 1 and then 0. The remainders will always be in the stack. 0, 1. So we can do till the divisions are completed. And then how we do the conversion? We simply pop the items and put them into the output string. So once we store these remainders into the stack data structure, then after the divisions are completed, you are done, almost done. You'll simply use a pop operation, remove the topmost item, put them as the first item into your string expression or binary representation, and then continue popping other items. And as you see, the base, this is the base of the stack, and it will be the last item in your binary representation. Any questions, guys? Since we are done with this conversion. Okay. So this is what I have done actually. I'm not repeating the same issues. So this is how we do the implementation in Python. And we are assuming that we have a stack class, which actually we have gone through a moment ago in the previous slides. We import it simply, and then we write our function, the definition, dividing by 2, and as you see, the input is the decimal number. Then we first create a stack data structure. Its name is remainder stack. And then if the decimal number is greater than 0, we do some divisions and we store the remainder. This is this operator is actually giving us the remainder from this division operation. And then what we do is simply put that remainder into the stack, and then to divide our decimal number once again by 2, and then we continue. Since this was giving the remainder, the decimal number is not changed, but we want to have a new decimal number, which is almost the half of the previous value. So we do division here, and then continue these operations until the decimal number is equal to 0. We will have many remainders, and these will always be in the stack data structure. Then we simply create a string. This is the initialization of the string. And then we do pop operation. As you see, we will do many pop operations until our stack is empty. And these items will be added to the end of the string. As you see, this is with a single expression, we can do that. And finally, we can simply return this string with the binary string, and the function will be actually completed with these operations. So now let's have a look at another area where we can use stack data structures. This is about the infix, prefix, and postfix expressions. And in the conventional mathematics, what we use infix operations. If you have such two operands and if you want to sum them together, then you first write one of the operands and then write the operator, and then lastly the second operator. And obviously we know that we have the importance of the operators are different. For instance, we don't have a parentheses here. Since multiplication is more important, we will perform the multiplication first and then do the summation. And again, since it's an infix operation, infix expression, we need to have these operators in between the operands. But let's have a look at the prefix expression. As the name implies, you need to put the operator before the operands. A and B are the operands, and my operator is a plus sign. So I put plus first and then the operands. But the meaning, the mathematical meaning of this expression and the first one in the infix version is the same. We are simply summing the two operands A and B. And the second ones are again the same. This is an infix expression. The other one is an prefix expression. So I see that we have a plus operation, summation operation. I see one operand, but after A, I see a multiplication sign. But if you want to do a summation operation, you need to have two operands. But right now, I just have A, so I need to continue, let's say, scanning this expression. Then once you come up B, right now you have two operands, but the thing is that I have two operators, plus and multiplication. Since multiplication is more important and it comes after the plus sign here, we need to first do the multiplication. This will give us another operator, another operand, I'm sorry. So we will have another number here, and we will have the second operand for the summation. So I can say that we need to have a kind of, let's say, expressions in implementation so that we will perform this multiplication first, and then assume that this is D, we will have such an expression now. And then simply we can do this summation operation. And in the postfix version, things are similar, just the main difference is that we are putting these operators at the end of the operands. So for the simple summation operation, I have two operands first and then the operators. And again, it's the same. If you look at the initial expression here, I have A, B, a plus sign, two operands plus sign, and then I have C, which is the last operand actually in the infix expression, and then I have the multiplication. But while doing this one actually by some programming approach, you should be careful, since if you follow the same approach here, once you see two operators, you shouldn't be performing the summation immediately. You should scan and then check the order of operators, check the operands, whether they are available or not, and then depending on some cases, you can perform the operation. We will have some examples in the upcoming slides, but if you have questions right now, we may talk about them, about the fundamentals of these prefix and postfix expressions. Any questions? No question? Okay. This is actually the thing from the same textbook. Yes, now we may spend some time on this example. And I want to actually contribute to this example, how we do the prefix, how we construct the prefix expressions and postfix expressions. So let's start from the prefix expression. Now we can write, or I may show you and then we may talk about here. As you see, this is completely different from the infix, the conventional expression. We have parentheses, we have always operators in between the operands, but this time we have many operators after each other. We then have some operands, we have another set of operators, some operands, some and plus operator, and last two operand. But how we actually do the conversion, and can we do it? How can we do it? By using the steps. So we said that we have parentheses. While scanning, we come up with left parentheses, right parentheses. So we need to perform the summation first. So I can simply write AD, and we need to have, since it's an infix expression, I need to have the operator in front of the operands. And then I have a multiplication here, which should be performed first. And the result of this summation will be multiplied with another operand. And since the operators are coming in front of the expressions, I need to have this multiplication here, okay? So we can say that this is represented with the help of these 5 characters. And then let's try to perform these. We have 2, let's say, summation and subtraction operation, and the result of them are multiplied. And this is how we write the first parentheses, D, E, and we have a minus sign in front. And then we have a similar one. This is plus F and G. So we need to perform these first and then have a kind of a multiplication operation in between these, right? So that's why we need to put the multiplication in front of the expression here. Now we are done actually with these. And the only thing we didn't include is this subtraction operator, right? So it will perform a subtraction operation between this first part and the second part. And that's why I need to have a minus sign in front. So if you combine these two, you will have such an expression. So I didn't want to make things complicated while discussing the stacks. We will do it in a moment. Any questions how I converted this expression manually into a prefix notation? No questions? Okay then. What about the postfix expression? Let's again do it manually. We say that in the postfix expression, we simply put the operators after the operand. So again, if I start with the first part, we have a summation operation in these parentheses. They need to be summed together. And then after this result is obtained, we will have another operator, which is C here, and they should be multiplied together. So I can say that this is the first part. And then what I do, I will now write the second part. Since we have again balanced parentheses, I need to first handle the things inside the parentheses. We are using the postfix notation, D and E, and they will be subtracted. And then what do I have? I have F and G, and we have a kind of a summation there. So this is the result of, actually we have another one. What is missing here? We have a multiplication of these two expressions. Since it's an postfix operation, postfix notation, I need to put that multiplication sign after the summation sign. Okay, now this is done actually. The only thing remaining is here again, the subtraction sign, and first part, second part. The second part will be subtracted from the first part, so I need to put that subtraction sign to the end of the whole expression. This is how things actually, how the infix notation is converted into a postfix notation. Any questions, guys? And this is the manual way. And as I said, while we are implementing this conversions, we need to use the stack data structure. Questions? Okay, I will continue it an example how we do the infix to postfix conversion. So we will do actually the second one is an example. We will try to find an automated way for conversion of the infix notations to the postfix notations. So yeah, this is important. If you look at the order of the operators, they are kind of reversed. If you didn't have any parentheses, that will be an exactly reverse operation, but due to the parentheses, it's an exact reversing, but kind of reversing operation. So if you look at here, for instance, you do the summation first and then the multiplication, but here we were first had written and the multiplication sign and then the plus sign, but it's reverse as you see. So it's better as you see since we have a reversing operation and we said that stacks are quite useful if you want to reverse anything. So we can easily use a stack data structure. And another thing is that once while actually we are scanning from left to right and once you see a left parentheses, and you should denote that and higher precedence will be coming. So if you have left parentheses, if you have seen a left parenthesis, then that means you need to perform the operations inside here first and then continue with the rest. So what you need to do, you should be actually on alert and take these operands inside the parentheses, and then once you see the right parentheses, then you should perform all the operations inside. But if you don't have any, let's say, parentheses, you should always consider the precedence of the operators, okay? The multiplication and the division comes first, and then comes the summation and subtraction. So while doing the scanning operation, how we are going to implement? In order to make it simpler, we will assuming that the characters, the operators, and the operands are all have a space in between. So we don't combine them. We don't have and let's say they're not face to face. We have an empty space in between. These are our operators, and we will be using letters as the operands. So now what we are going to do in the implementation, we need to have an empty stack for the accumulation of our operators and have an empty list for the output of this conversion. So once you are done, this output list will be the final actually value you are looking for. And then what we are doing as a second step, we will simply convert the given string into a list. So if you have, let's say, an expression having 10 different items, then you will put each of them into different items of the list, one by one. So this will be the second step. And then once you have the list in your hands, you can simply scan your list from left to right. And while scanning from left to right, and when you come up with an operand, which means letters, you will append them to the output list. So you will simply output them. And if you look at the, let's say, the expression here, so when you see an operand, you will simply output it. So it will be appended to the output list, like this one. But if you see an operator, you need to put it into operator stack. So if you see a left parentheses, again, you should put it onto the stack so since it's a kind of an operator. And while doing other operations, you may come up with the right parentheses. Then what you do, you need to pop all the items in the stack until your left parentheses is removed. With the help of this approach, you make sure that the operations inside the parentheses are performed, and you can continue with the rest of the expression. So while you are popping, what you do, you simply append all the operators to the end of your output list. Actually, this is what we have done. So we have a left parentheses, we put it into stack, we come up with a plus sign, we put it into stack. So we have two items in the stack, left parentheses and a plus sign. So once we see a right parentheses, what we do is simply output, pop this plus sign and put it to the end of the list. So we simply append this plus sign to the end of output list, and we will have A, B, and plus. And since after plus we don't have any operator, so we will see a left parenthesis, which means that we are done and we can continue scanning our list. So what about operators? This is actually the things we mentioned. Once you see an operator, you simply put them on the stack. So there is an important issue. You need to actually remove any operators which are already on the stack, which has a higher or equal precedence, and append them to the output list. And this becomes important when you don't have any parentheses and many operators in your stack. In our example, things are not that complicated. It's much straightforward, but you may have more complicated expressions, and in them you need to do such kind of checking. Once you come up with an operator, you need to check the order of your operators in the stack and decide on which operator should be actually popped first, which operator will be popped the second. So you'll continue the scanning operations until you don't have any operators left in the stack. And then that means you are done, and the resulting actually output list will be the value you are looking for. This is actually, we had gone through a moment ago. I'm scanning from left to right. This is an operand. I put it into output list. This is an operator, put it into stack. Operator, output, operands, output simply. You have a plus operator, put it into the stack, and then you have actually before putting this plus sign into the stack, what we do, we see that this plus sign has less order, less precedence than the multiplication. So we need to actually pop this multiplication sign before adding the plus sign into the stack. Since we don't have any parentheses, so it's a bit important issue. You shouldn't have a multiplication sign underneath this plus sign. So that's why we output the multiplication sign before adding the plus sign into our stack. And then we continue scanning. After plus, we have C. This is an operand, so we need to simply put it into the output list here, C. And then we have multiplication sign. We need to put it into the stack. And underneath, we have a plus sign. Okay, no problem, since multiplication is more important. So we don't need to pop plus first and then put the multiplication into the stack. We can simply stack them together. And then you finally come up with the last operand, which is D. You need to obviously output it and append it into your list. And then we don't have any letters, any operands remaining, so we need to empty the stack. In stack, we have two operators left, so we simply pop them one by one, the multiplication sign, and then the plus sign is popped, and they're added to the end of the output list. Any questions, guys? Yes, this is how we do the conversion from infix to postfix. While we are scanning from left to right, once you come up with an operand, you put it into output list. But once you see an operator, you need to put it into the stack. But if you have multiple operators in the stack, you need to consider the precedence of them. If, for instance, here multiplication is important, then you should pop it and add it into the output list. But if there is no importance, then you can simply put it into the stack and continue with scanning. Well, again, once you come up with operands, directly send them to the output list. Once you come up with an operator, put it into the stack and check the order of them. If it's proper, then no problem. You can continue scanning your expression and output all these operators. Once you are done with the scanning and have some operators remaining in your stack, then you can simply pop them and put them at the end of your output list. So this is how we do it in Python, how we do this conversion from infix notation to postfix notation. Obviously, since we are using a stack data structure, we need to import the stack class. And then we have some initial, let's say, definitions about operators. To make it simpler, we have an precedent, the importance of these actually operators are defined with such numbers. So the most important one is left parentheses. Actually not, it's not defining the importance, but some kind of ordering. Multiplication and division has the same value, plus and minus signs has the same value, but the left parenthesis has a different value. So now what we do, we create an empty stack data structure. As we discussed in the previous slide, that we need to have a stack data structure for the storage of operators, and we need to have an output list for the result, for the postfix notation. This is what we do. We create a stack data structure and create an empty output list. And then what we do, we get the infix expression and try to split it and try to have all the items in our string expression into the list. So they will be divided into some items in our list. And then things will be easier. We can easily scan the operators and the operands in our token list. So this is a for operation, for loop. We do this operations for each token in our token list. And if the token is a letter or it's a number, what we do, we simply append these tokens to the end of the output list. And this is actually what we have done here. Once you come up with an operand, you directly output it into the output list. This is what we do here. But if you see in left parentheses, then you need to put it into the stack data structure and then continue with your operations. If it's on right parentheses, then you need to pop the operators inside your stack and you stop when you come up with an left parentheses. In other cases, if the stack is not empty and if you don't have any problems with the order of the operators in your stack, then you will output these operators and again add it to the end of your output list as we have done in the previous slide. And then this is actually how we run the for loop, and we do it until actually our stack is empty. If it's not empty, once we have done the scanning, once we have done with all the operands and operators in your list, then you should do this popping operation. And this popping operation is here, these two expressions. If you are done with scanning, but you still have some items, some operators left in your stack, then you can simply do popping operations as the number of operators you have in the stack, and then conclude with the function. At the end of these operations, all these operations, you will be done with the conversion. Your initial infix expression will be converted into an postfix expression or notation. Any questions, guys, about the implementation of this conversion, how we do it from infix to postfix? Okay, now let's continue with the postfix evaluation. Now that means we have the postfix expression, and we will do the math by simply using this postfix notation. We don't need to convert it into an infix notation and then follow the conventional rules. We don't need to do that. We can directly do the evaluation, directly do the computation by just simply going through the postfix notation. So obviously, our expression is already in the postfix notation. So this time, as opposed to the conventional way, this time the operands will wait instead of the operators. So while again scanning from left to right, we have operator 4, operand 4, operand 5, operand 6, and then we have the operator multiplication. So once we have it, then we need to do the multiplication with the last two operands in our, let's say, again, say, stack data structure. And then put the result into the stack, and we will have 4 and the result of this multiplication, which is 30. So we have two operands this time in the stack, and we come up with a plus sign while scanning. So once you do that again, you need to do the math and sum these values. So this is actually what I mentioned. Once you do a kind of an operation here, the result should be put onto the top of the stack. And once you are done with all the operators, then you shouldn't have any more operands in your stack. You should just be left with a single value in the stack, and that will be the result of your postfix expression. And so things are not that complicated. You will simply pop the result and return it as output of your expression. And this is the graphical representation of the same postfix expression, 4, 5, 6, multiplication and plus. So we put 4 into stack, 5 into the stack, 6 into the stack, and once you come up with a multiplication while scanning, then you need to pop twice and do the operation. So the result will be stored into the stack once again, and then you should continue with scanning. We are here. Now the next operator is plus sign. So again, we will pop the values in this stack twice, do the operation, and put the result into the stack. And you'll see that we are done with the scanning. That means we are done with the computations, and we can simply stop scanning and output or pop the last item in our stack data structure, which is 34 in this example. Another expression, 7, 8 plus, 3, 2 plus, and a division operator. So we put the operands into the stack. Once you come up with an operator, you pop twice and do the math, and then while scanning again, as you see, we come up with some operands. We need to push them into the stack, 3, 2. Now we have an operator. So pop these values twice, 2 and 5, do the summation operation, and put the result back into the stack, which is 5. And then lastly, we see a division operator here. So we need to divide 15 with 5 and put the result into the stack once again. And this will be the result of our operation. At the end, you will simply pop this item and give it to the other, let's say, expressions in your implementation. Any questions, guys, about the postfix evaluation? So in summary, we need to have an empty operand stack. We need to convert the string into a list and then scan from left to right. And if it's an operand, you need to put it onto the stack. If it's an operator, you pop twice, do the math, and put the result back on the stack. So it's not that complicated. You can simply pop the last item in the stack and done with this evaluation. And this is how we do it in Python. We create an empty stack. We split this given string into some list items, and we start doing the scanning operation. If you come up with an, let's say, operand, you put them into the stack. But if you come up with an operand, you optimize, do the math, and then push the result into the stack. So this is how we do it. And to make it simpler, we have a definition for the operators. These are operators, and their mathematical expressions are written here.